Mr. Pei. Today I'm going to discuss with you another example of the KSSM Physics Paper 3. The topic I'm going to discuss with you is about one of the compulsory experiment at the Form 5 Chapter 2, which is the experiment 2.3 at your textbook, page 68, which is to determine the relationship between the buoyant force and the weight of the liquid displace. However, I will do some modification for the experiment 2.4, which will be to determine the relationship between the mass and object to its volume. And as you know that our paper 3, Physics KSSM, they will have two different type of the question. They are the Tugasan Amali, berpandu, and another one will be the Tugasan Amali, tidak berpandu. And for today's discussion, we are going to discuss the question in the type of the Tugasan Amali, tidak berpandu. So let us go through together what is the pattern for the Tugasan Amali, tidak berpandu. Basically, this is experiment 2.3, which, as I mentioned, that they will be at your textbook, page 68. They will be at the subtopic 2.5 regarding the Archimedes Principle. So for the experiment, the aim for this experiment will be to determine the relationship between the buoyant force and the weight of the liquid displace. Okay, so as you actually already did this year, I think it will be a few months ago, okay, together with your teacher, so that the main three important information or knowledge you go through in this experiment is, number one, you have to know that the buoyant force, okay, buoyant force acting at the object here will be equal to the weight of the fluid displace. So you can see when you immerse the salted weight, okay, into the water here. So you can see there is a water displace at the beaker. Okay, and then the second, through this experiment 2.3, you can get to prove this formula, which is related to the buoyant force. The rho will be the density of the liquid, V will be the volume of water displaced, and G will be the acceleration of gravity. And besides that, with this experiment, you also know that the buoyant force will be equal to the weight of object in the air. So it will be at the figure A. Okay, will be here. So the weight you measure by using a spin balance will be the weight object in the air. And then when you immerse the salted weight in the liquid, the weight, you can see that there is a decreasing of the weight when the salted weight is displaced in the water. So you have to record down. So the difference between the weight of the object in air and water so be equal to buoyant force. So there will be a loss of the weight, okay, when the object immersed in water. However, as we mentioned that I will do some modification for the experiment 2.3. So we will relate that the volume water displaced, which is at the beaker here, okay, will be equal to the volume of object immersed. Okay, so let us go through together what's the question I'm going to ask in my discussion today. Okay, so as you know that the candidate will be get a checklist here. Okay, so let us go through the question together. So the instruction here, you are not allowed to work with apparatus in the first 15 minutes. This period is used to check your apparatus leads, read the question, and plan your experiment, which will carry out. Mark in the box provided to check the material apparatus prepared and supplied. Okay, so that means that the 15 minutes is actually, you have to check the apparatus for 3 experiments for different subjects. That will be the biology, chemistry, and physics. If I say you taken for only 2 subjects, there will be only 10 minutes provided for you to check the apparatus list and read the question and also plan the experiment. Okay. Okay, so this is the checklist for the apparatus and material provided in my question going to discuss today. Okay, so first, you will get a cylinder glass jar with quantity 1. Second, you will get a meter rule, also with 1 quantity. And you will get 5 pieces of plasticine. Each plasticine will be 20 grams. Okay, so if let's say you get all the apparatus and material listed with correct quantity, you can just tick. Okay, you can just tick the checklist here, and immediately you have to go to the question. Okay, because you have only 5 minutes to check and plan for each subject, including the physics practical test. Okay, so as I mentioned just now, the question we are going to discuss today will be regarding the Tugasan Amali, tidak, berpandu. Let us go through the question together. You are required to carry out the experiment to study the relationship between the mass, and its volume. And the question asks you to plan your experiment by using the apparatus and material provided. Your procedure should include method to handle variable 4 marks. So that means that for this question A, you need to list all the related procedure, and the 4 marks will be given. So how we are going to do for this type of question? So the first step, you have to identify the manipulated variable and the responding variable in the question. So from here, you can see the sentence here is actually the M for the experiment. So the mass you are going to do in the question here will be represented as a manipulated variable, and the volume will be the responding variable here. So this is the first step you are going to do for the question A. Then second step, you have to sketch the diagram, which is related to the MV and RV settled in the M in the question already. So basically, you can just sketch the diagram, okay, so that you can basically imagine what you are going to do in the real practical test after you read the question 5 minutes later on. Okay, basically you'll be like this now. Okay, so the water will be poured into the provided glass jug. Okay, and then when you put in the plasticine, so for sure that the water level will be rise up. So as we know that the apparatus provided is not given any measuring cylinder. So how to get the responding variable, which is a volume here? So from our mathematics experience that you learned already, the volume will be equal to area multiplied with the height. So the delta height actually represents as what here? So the area will be the cross-sectional area for the gas jar here. So will be pi r square here for the area for circular. Okay, so the r referring to the half of the diameter. The d here is referring to diameter. Okay, so that means that you have to measure the diameter of the gas jug by using the ruler, because the ruler is provided in the apparatus checklist just now we mentioned. Okay, and then how we get the delta H here? So firstly, we have to measure the height of the level water here before we immerse the plasticine. So will be stated as H naught. And then the second, when you immerse the first plasticine, so the water level will be rising. Then you have to measure your H1 by using the ruler also. Okay, so the delta H here will be represent the volume of the plasticine displace, okay, which is related to the Archimedes Principle here. Okay, so after that, you actually already know what to do, so you may start your experiment. So let us see together how I'm going to conduct the experiment in this question.
Based on the checklist, water, 5 pieces of plasticine with 20 gram each piece, cylinder, glass jar, and meter rule is provided. Before the plasticine is immersed in the water, the diameter of the cylinder glass jar V is measured by using the meter rule. The diameter is about 7.5 cm. Then pour some water into the cylinder glass jar. Before the plasticine is immersed into the water level are measured by using the meter rule, which is labeled as H0. Please ensure that your position of eyes is perpendicular to the scales of the reading to avoid Parris error, and the reading is 7.5 cm. Next, immerse slowly the plasticine into the water and measure the height of the water level H1 by using the meter rule. The reading is about 7.9 cm. Next, immerse in other plasticine and measure the water level with the meter rule, which is about 8.3 cm. Third, plasticine is immersed into the water and the height of the water level H3 is measured by using the meter rule. So you can see that the measurement is about 8.7 cm. Next, fourth plasticine is immersed into the water and the height of the water level H4 is measured by using the meter rule. The reading is about 9.1 cm. Last, immerse the fifth plasticine into the water, measure the height of the water level with meter rule, which is about 9.6. So that's all for the simulation. Thank you.
Okay, we have already finished doing our experiment, and now we have to immediately to answer our question. So for question A, so you have to give the diagram and the procedure, as the question asks us to give the procedure for the experiment regarding the M given by the question. So which is to determine the relationship between the mass of the plasticine and its volume, 4 marks. So you have to give the 4 points. So what is the 4 points you are going to write in this question? So first, you have to give the correct diagram with label and symbol used. So here, as the mentioned just now, you have already sketched the diagram in your question. So here you have to draw the diagram with label for each apparatus and the symbol you're using here. So for the first statement, you can just set up the apparatus as shown in diagram. So this will be your first mark. And then the second, you have to give your first manipulated variable and record your responding variable. So as a discussion just now, our manipulated variable will be the mass of the plasticine. So that means will be the first mass of the plasticine immersed into the water here. The mass for the first plasticine will be 20 gram, will be 20 gram. So, and the responding variable here, as mentioned just now, will be the volume. Will be the volume increase. So the volume you can calculate by using the formula pi r square area for circle multiplied with the h here. So here will be the h1. So you can measure both diameter and also the height of the water level here. So it will be h1 d together with the h0 here. Here, how many decimal places you have to take for measuring your h1 and diameter here? So you can look at your ruler here. So the sensitivity, for the meter rule in my diagram here will be about the smallest division here is 1 mm. 1 mm or 0.1 cm. So that means you can give 1 decimal place or 2 decimal place where you can see that you can look at the first smallest division here. So there will be half between the first division. So yeah, let's say I draw the ruler will be like this. So here first and here will be the first reading, which is 0.1 cm or 1 mm. So in between here, if I say your water level is here, so that means you can take as 0.05. So your decimal places maximum will be two decimal places only, and the second decimal place will be 0.005 or 0.00. So they will be 0 and 5 only. This is not possible for you to measure 0.01, 0.02 or others. So there will be only 0.00 and 0.05 for your second decimal if you're using the meter rule here. Okay, so I hope that you can understand how you can give the you can give your decimal places in your measurement correctly, which is according to the sensitivity of your apparatus here. Okay, so the statement here you have to give before the plasticine is immersed in water. So we'll be referring to diagram 1 here. The diameter of the glass jar, which is with symbol D, and the height of the water level are measured with meter rule, which is with symbol H0 here. So calculate the volume V0 with the formula I mentioned just now, which is a pi r square times height. So the r will be the diameter divided by 2 so you can get the radians. And then the third procedure here will be a piece of the plasticine with the mass of 200 gram. So it's 20 gram is slowly immersed into the glass jar, which is showing at the diagram 2 here. And the height of the water level, which is H1, have to measure, and the reading have to record it. And then you have to calculate the volume. Okay, the volume for the diagram 2 here, which is used by using the formula V equal to pi d over 2 square times Hi. So the I referring to the numbers of plasticine immersed. So if I say we have only 1, so the height will be referring to the H1. If I say we immerse another plasticine here, so that means the water level will be rise more. So you will be measured as H2. Okay, so here will be always changes for the value Hi here. And the D will be always the same because this is the diameter for the opening mouth for the glass jar here. Okay, and then the fourth mark here, you have to give the repeating value for your manipulated variable and the responding variable. So normally it will be at least 4 times. Total you will have the 5 manipulated reading and together with the responding variable. Okay, but actually if I say 3 points is actually enough already for the plotting the graph. But normally we will request for the minimum 5 manipulated variable here. You can just write as repeat the step 2 here. Actually it's repeat the step 3. So you can repeat the step 3 with the mass of the 40 gram. So the 40 gram of the plasticine referring to two pieces of the plasticine you have to immerse in the water. And then the 60 gram referring to the 3 pieces of the plasticine, and 80 gram and also the 100 gram. And then for the each height of the water level rises, you have to measure and recording. And then you have to calculate the volume with the formula mentioned in step 3 here. Okay, so this will be 4 marks you will get if you write with the format I give you now. So firstly, you have to draw the diagram and mention, set up the apparatus as shown in figure. And the second, give your first manipulated variable and record your first responding variable. So here will be the volume for the RV and MV for the mass. And then third step here, you have to repeat your manipulated variable at least 4 times and give your responding variable 4 times. Total, you have 5 manipulated variable and responding variable reading here. Next will be the question regarding the tabulation. So here will be 4 marks. let us go through the question together. So here we have the two questions for the tabulation. So the first, set the volume of the water, V0. Just now I mentioned already, there will be the volume of the water in the glass jar before the plasticine is sorted into the glass jar. So as I mentioned, two reading will be measured, which will be the diameter of the glass jar. So which is 7.5 cm, which I actually show you how to measure in the stimulation just now. And then the second, I also show you how you measure the height of the water level in the stimulation I showed you just now. So which is also 7.5 cm. And you can have your own reading. So let's say you put less water, so definitely your height of the water level will be less, and your water level will be high if you put more water. But please make sure the volume you put in to the glass jar must able to immerse 5 pieces of the plasticine given, and the water is also cannot be too much, because if you give too much of the water, so that the water might be flow out, okay, with the maximum number of the plasticine we put in. Okay, so as we mentioned, for the V0 we can measure, we can calculate by using the formula pi r squared by h. Okay, so which is the formula for cylinder actually. Okay, so we substitute the d with value of 7.5, which is measure the diameter of the glass jar here, and then another h0 also 7.5, which is the height of the water in the glass jar before the plasticine is put in the water. So we get 331.38 cm cube, okay, for my V0. Okay, and here actually the decimal place I put 2. They actually is no fixed decimal places for the volume here. Okay, so as long as you can plot the minimum accuracy, okay, for your graph later on, so they will be fulfill the requirement. And the second, you have to give the unit here for your answer. Okay, so this will be the first mark if you get your volume with correct unit and together with the correct unit here. So the second, so calculate your result for all value of m, vi, and v in the space below. Okay, so the m represent as the mass of the plasticine immersed, and the vi will be the volume of water with I numbers of plasticine immersed, and v will be equal to v0 minus v, will be vi minus v0. So what is that? So here you can see the m will be the numbers of plasticine we immersed into the water here. So the first 0 gram, that means there will be no any plasticine put into the water, and we get the initial height will be 7.5. Second, when we put in our first plasticine, so which is 20 gram, and the decimal place will be 1, which is actually mentioned in the checklist already, so we just follow. And then the hi, the initial height of the water, with placing 1 plasticine will be 7.9, okay, which is rise when we put the plasticine into the water lah. So the 40 gram referring to 2 pieces of the plasticine put in, and the water level height will be increased to 8.3. And as I mentioned just now, the sensitivity of the ruler can be 1 decimal place, okay, or 2 decimal place. Okay, so for the first tips, okay, actually here you have 3 tips have to fulfill to get the full marks here. So the first will be the symbol. So you have to put the symbol for each column here, and referring to the mass of the plasticine immersed. Vi will be the water, volume of water, with I numbers of plasticine immersed. Hi will be the height of the water level when we put in the plasticine into the water. And V, you just follow the question given here, will be Vi minus V0. So that means actually here will be the delta V lah, which is actually represented as the water displaced. Okay, water displaced by the plasticine, and also can be represented as the volume of the plasticine actually. Okay, so the second in your table must be have the correct unit. So here will be gram for mass, cm for height, cm cube for the volume here. And the third tips, as I mentioned, you have to give the correct sensitivity of the apparatus or the instrument used. So here we're using the meter rule. Okay, and the first here, the decimal place is gram with 1 decimal place. Actually, this is already given in the checklist already. Okay, you just follow. And you can see that we need to have the consistency of the decimal place here. So all the reading here must have the 1 decimal place for the mass. And then for the meter rule, as I mentioned, you can give 1 decimal place or 2 decimal place. But the second place here will be 0 or 5 only. This is impossible. You get your reading as 7.51. So they will be out of the sensitivity of the meter rule already. So 7.50, 7.55 is accepted, which the water level is at the middle of the segment here. So you get 0.05. Okay. So you can see my reading here, I just give 1 decimal place. So as I mentioned already, for the second decimal place, the possible value here will be 0 and 5 only. Okay, so for here, this is the way how you measure. So that means you have to avoid the paradox error when you taken the reading. Okay, so for VI, so you have to using the formula we stated at the experiment. For VI, you can using the formula stated in the procedure, which is pi r squared times h. So the h here referring to the height of the water level. So here we can just, I can show you one of the example where we place the 1 plasticine into the glass jar, so the water height will be 7.9. So you can just substitute 7.5, which is referring to the diameter for the opening mouth of the glass jar, which is always the same, and the HI is referring to the height for numbers of the plasticine put into the water. So here, when we put in 1 plasticine, so the water level height will be 7.9. So you get the value will be 349.06 here. Okay, so the others will be using the same method to calculate, and you will get the value given here. Okay, and then for the next, the V, you will be using the formula given by the question, which is VI minus V naught. So here, the VI will be 331.38, and the V naught is also the same value. So minus you get. Okay, so before I showing you the reading for V, you can see for this column, all the reading will be have 2 decimal places, which is consistent. So we have to give the same or consistent decimal places for each column here. Okay, so for the first column, 1 decimal place. Here, the height will be 1 decimal place. For the volume here, I given 2 decimal places. Okay, so we go back to the V. So for the, as mentioned just now, the V, you will using the formula here, VI minus V naught. So for example, here the V1 here will be 349.06. So according to the formula, you minus with V naught, which is the 331.38, you will get 17, you will get 17.68 here. So the others will be using the same method to get the value. Okay, will be listed here. Again, you can see the decimal places I stated here is consistent, which is 2 decimal places here. So if you fulfill these 3 tips are given here, so you'll get full 3 marks for the tabulation here. The next C will be the question regarding the graph. In my question, I designed here will be 3 marks. Okay, so let's see how you can get the full marks for plotting the graph here. So the question here will be on the piece of graph paper, plot a graph V against M. So you'll get the data from the table just now we already tabulate. So will be here. So the M will be with this reading, and the V will be with this reading. Okay, so there are 6 tips you have to remember when you're plotting the graph here. Okay, so firstly, ensure that your axis is within the graph, okay, cannot too big or too small here. So the firstly, you have to give the symbol correctly for x-axis M here and y-axis V here. So because the question asks us to plot V against M, so that means the V will be at y-axis and the x-axis will be the M. Second, give correct unit for each axis. For the mass will be gram and the volume will be cm cube here. Third, you have to give the correct scale. So that means firstly, you have to identify the minimum value and maximum value for your x-axis and y-axis here. So for example here, our minimum value for our x-axis will be 0 to maximum 100 here. For the V will be 0 to 97.21. So your scale must be including the minimum value and the maximum value in your table. And second, your scale must be in the multiple of 1, multiple of 2, multiple of 5 or 10. Okay, so we cannot give the scale with multiple 3. For example, 3, 6, 1 unit represent 3 cm, 6, 9. Or we not accept 1 unit represent 4, 1 unit to 6 and others lah. Okay, so we have to follow multiple 1, multiple 2, multiple 5 and multiple 10. So here you can see my x-axis, the scale I chosen here will be 1 unit to 20 gram. Okay, and second, you can see my y-axis scale will be 1 unit. 1 unit will be here, 1 unit to 10 cm cube here. So which is a multiple of 10 here. Okay, next, make sure your size of the graph must be at least 4 times 5 unit. There is a 8 cm times 10 cm. So that means your graph must be at least half of the graph here. So the 4, that means will be here. Okay, 4 unit will be here. And then the 5 unit will be at least, you need to draw here. So that means the size of your graph must at least here. 4 with 5 unit. Okay, too small, the mark will be deducted. So the 5th tips here will be plot points correctly. So here we have 5 points. Okay, so you have to define one small box here is actually the smallest division. So here you can see for the y-axis here, the smallest division here will be 10 divided by 10 box here. So the smallest division for y-axis will be 1, and then the smallest division for the x-axis will be 20 divided 10, you get 2. Okay, and then here for the first reading, so you can see 20. So there will be need 10 box. Okay, 10 box here. And then for the V, there will be almost 18 here. Okay, because we are unable to plot smaller as 17.6 here. So we can round off to 18. So the first point will be here. And then the second and others will be like this lah. You can plot according to the reading. Okay, make sure that your graph is the baseline pass through the origin here lah. Okay, so how we can draw a baseline here? So from my baseline here, you can see there are the point lower the line and also above the line. Okay, so you must choose the baseline where there is the point at upper and lower of the line. All the point at the bottom of the line is not a baseline, and all the point above the line you also consider not a baseline. And second, you must make sure that the distance of the point to the line at the upper point and also the lower point must be equal. So my one here will be also almost the same. So here we consider the baseline. Okay, so this is 6 tips for plotting the graph, and you can get the full marks if let's say you fulfill these 6 tips here. Okay, so the next will be the data analysis. So the question I designed here will be 4 marks regarding the data analysis. So the first question, the question asks you, okay, to calculate the gradients, okay, with the symbol K. So in your graph, which is actually is the mass against V, okay, show on the graph how you determine the value of K, 2 marks here. Okay, so this is your graph. So you have to draw right angle triangle. So here will be the right angle triangle, and your right angle triangle must be big enough lah. So must at least half of the graph here. Okay, so this is the first step, and you have to show the right angle at your graph. And second, you have to choose 2 points in your graph here. So the first will be 0, 0, I choose. And then the second, I will choose the last endpoint here. So referring to 100 and about 97 here. Okay, so for the gradients, the formula will be y1 minus y2 over s1 minus s2. So my y1 can be here, and my y2 can be here. My s1 will be here, my s2 will be here. So I just substitute to the formula. So I get my reading here will be 0.97 cm cube per gram here. So you must give the correct decimal places with the correct unit here. Okay, and the last question here will be another 2 marks for determine the density of the plasticine by using a graph here. Okay, so here how we can get the density through our graph, you can look at the unit for the gradients here. So as we know that the density is equal to mass over volume. So the unit for mass will be gram and the volume will be cm cube. So which is actually reverse for the unit for gradients here. So that means the density is equal to 1 over k. Okay, is equal to 1 over k, or you can mention that they will be inversely proportional, okay, to the k here. Okay, so we can just reverse 1 over our k. Okay, we get 0.97 here. So you get your reading is about my reading 1.03 gram per dm cube, which is the unit request by the question here. Okay, so the first mark will be substitution. Second mark will be the answer with correct unit here. Okay, so the plasticine is will be sink into the water. So that means your reading here must be greater than 1. Okay, as I'm checking in the internet, so the plasticine value is about 1.34 gram per cm cube. Okay, so in my opinion, if I say your answer is almost close to the 1, is greater than 1, they will be accepted lah. Okay. Okay, so that's all for the question I designed, which is total 15 marks for the each question of the paper 3 in physics. Okay. Okay, here I want to show you some of the extra questions that can be asked in my question design here. Okay, which is to determine the relationship between the mass and also the volume here. So the question can be asked you to state 1 precaution that should be taken to improve the result of this experiment. Okay, so the position of the eyes is perpendicular to the scale of the reading to avoid the Barrett's error. So this is one of the question can be asked. And then the second, so state the relationship between the V and the M here. Okay, so our graph here, actually you can see that there is a straight line pass through the origin. So that means the relationship of V to M will be directly proportional. So you can just mention V is directly proportional to the M. Okay, so that's all for my discussion in the experiment regarding the principle of Archimedes. So I hope that my discussion today can help you to understand what you want to do in the question, especially in the type of the Amali, tidak, berpandu. That's all. Thank you.